So this is a really old project that I had that I produced a long time ago in university. But what I'd like to highlight about this project is that it I went beyond what was necessary to complete the project. So I'll just get straight into it. Right now, the project has this basically um, we had to produce an AI that could play Tetris. So what I did here is that I've programmed the rules of Tetris as a library, and I'm also created the AI for it as well as a separate entity. So this part is the Tetris library. Um, it's a massive C# file, but basically it contains all the rules and information required to run a Tetris game. Um, and the AI itself is separate as its own class, so that I could separate the two um, and modify them as two existing objects. So the AI basically interacts with the game, and the game feeds back the information back to the AI. The AI itself um, has uses heuristics. So it uses numbers, like a set of numbers, to determine um, how to play. Um, it analyzes the game board of it analyzes the game board of the current state of the game. So it takes a look at the game board and identifies positive and negative features. And depending on what it values in its heuristical weights, or as I like to refer it as the DNA string, it determines whether the board is in a good state or a bad state. And it makes decisions on the next piece and where it should be put and with a given rotation. So this is it in to demonstrate. So we've given the Tetris AI a buffer. So at any point when it's given a piece, it can store a buffer in up to 5. So it's got five places to store a piece. That was the outline. That was the limits of the game that we were given. We were able to give the AI a buffer to store pieces and use any piece it deemed necessary to solve the current state of the board. So it's not very clearly shown here. The pieces aren't dropping on the top. The program is just simply putting down the pieces where it deems it necessary. And this is the piece being placed. So you have the 5 pieces it's stored in memory, and the piece that is currently used from that memory. And as you can see, it's doing quite well. I've used to get this AI to this state. I've used a technique called particle swarm optimization, which is basically can be thought of as flocking birds. When in a flock of birds, and in a given area of 3D space, usually birds will tend to find food in that area, and the flock of birds will then flock to that area. Training the AI was similar in concept. Instead of birds, we initialize the heuristical weights, or the DNA. We randomize the DNA of the starting generation, and we initialized each of these the starting generation of AI Tetris players we randomize their locations in a given space. Um, with flocking birds, you might have 3 dimensions, but the AI can analyze the game in 8 different ways. So it looks for things like gaps, holes, ridges, how uneven the surface is, and the how high the current game state is, like how high is the debris or the blocks left over. So it views the game in 8 dimensions, and so we randomize these particles of birds in 8 dimensions, and from there, in an 8 dimensional space, they encounter positive ways to play and negative ways to play, and during the next iteration, the entire swarm is notified, and they will gravitate towards that area of positive space, or in this case, habits that define a good Tetris player. And eventually, all the particles will swarm around this area, searching all points in between. And every iteration this happens in the trainer, the whole swarm is notified, and the most fit particle is then gravitated towards. And this eventually leads to a very, very strong heuristical Tetris player. The only at the moment the Tetris player doesn't learn between games because it's already been trained. I have a trainer that basically initializes several AI players, and depending on how much time you want to train it for, or how many games you want to train it for, the processing speed is longer. So I have a written report that details the science that we've tried to experiment with here. So we've tried to alter how many particles that we've initialized in that 8 dimensional space, as well as the results of tinkering, like changing the conditions, how well a Tetris player can deal with changing conditions. So, for example, increasing the buffer size. How would a Tetris player deal with that? How would their weights change, and so on. So I have that report ready for viewing if you want to. So yeah, so as I've been talking, as you can see, it's making very optimal decisions, keeping the height of the game state rather low. And yeah, that's it for demonstration. If you want further proof that this AI can deal with anything we send it, right then I gave it a random stream of 1,000 pieces, I think. So what I could do here is I can modify what we want. So with a Tetris game, a Tetris game, there are 2 variables to randomize. We can use a random stream of pieces to send at the AI, or we could use a real stream, a stream that we can determine ourselves. So we're going to go ahead and set this to false. So if this variable is false, it will then ask us to determine a number of pieces to give it to.